Alright, welcome back to the broken state that we left our server in from last time. So we've got this injection manager factory not found. There are a few different Jersey injection, dependency injection libraries that we could use. The common one you use with Jersey is HK2. So we'll come over to our web browser here and go to the Maven repository and search for Jersey HK2. Alright, here's HK2 here, the latest version 3.03. We'll copy this. We'll come over here to our top level POM and paste in right here. .inject after our Jersey bomb. And we'll copy paste this and also include it up here in our tutorial API REST. I'll go ahead and document these just a little bit. All right, just to make it a little bit clearer what these dependencies are used for. Okay, so now that I've updated our POMs, let's do a Maven reload project, make sure these are on our class path. We'll go ahead and restart our server. And we'll just rerun that same curl we ran last time. Okay, and good to go. We've got our text plain content back, right? We specified text plain here. We specified /test as our endpoint, which is what we used here. This REST endpoint is within the API server or API application, which is mapped to the /API context. So that's where the /API came from here. And we returned the string hello from our test REST endpoint, which was what we received back. So this is looking good. We've got our test resource endpoint up and running. We're ready to add additional resources and get rid of this test one and put real ones in here at some point. We did get some red here in our output. I don't know exactly what these mean right off the top of my head. Waddles we can disable. We don't really care about that. So no need to see this warning message. These warning messages aren't actually using our logging, so that's another potential issue. It looks like Jersey by default doesn't use SLF or J, so it's not using our logging framework that we currently have set up. That's why it's being shown here in red. It must be using system.error.println, and the format is different. So we'll revisit these problems in the future. For now, I'd like to backtrack a little bit and clean up what we currently have. We've got a bunch of stuff hard-coded in here. We've got ports hard-coded. We've got passwords and key stores hard-coded, paths to web files. So basically, we're hard-coding a bunch of different things in here, and really we need to update this code to accept configuration and pull these configurations in so that we can configure these kind of on the fly without having to change our code base. Before we do that, let's do a fresh Maven clean install. Let's make sure our project builds, and if it does build, then we'll push our current working changes up to GitLab. Okay, so we do see this unused declared dependency. We did add this to fix our dependency injection problem, but we're not actually using any classes here. We are going to use classes at some point in the future. Likely, we'll probably update our API application to add some custom bindings, a new abstract binder. I forget what those look like off the top of my head, but something like register new abstract binder. Okay, yeah, so here's a HK2 utility class. So if I'll just stick a logging name here. so it didn't know what login classes I was talking about because we don't have SLF or J as a dependency. So I'll go ahead and add that. All right, so now if I do a Maven reload on this module, it should pick up our logger. Okay, so now we're actually using an HK2 class. We'll update this in the future. This, by adding things in here, we can allow them to be dependency injected into our resources, which we'll do later on when we actually need some dependency injection. For now, we're just doing this just to fix this dependency error. So let's build it and make sure it still works. Okay, we didn't actually fix the problem, we made it worse. So now we're using HK2 API, and we're still not using Jersey HK2. So what I'll do is I'll come in here. What are we using? Okay, I'll copy this. Oops. All right, so I'll go ahead and add this org.glassfish in here. All right, and I'll go ahead and get rid of this one here. Actually, I take that back. I'm going to leave this here, but I'm going to add it to our ignored dependencies, because we want this here because it fixes the missing dependency injection problem. Yeah, it fixes this injection manager factory not found. So we do want it, but since we're not actually using any classes from there, I want to ignore it in here. Okay, these are all sorted alphabetically, so this looks good. It's a little bit of a pain, managing all these dependencies and what we're including and what we're excluding and what we're ignoring and all that. But this is the best way to get consistent, stable, well-defined builds without dependency convergence problems, etc. So yes, it's a pain, but it's worth it in the end, in my opinion. All right, so let's go ahead and rerun our Maven command. Oops, so I added this one, but I didn't specify a version. Let's look and see what versions exist. .302 is the latest. We'll copy this, and we'll go to our top level POM. Add that in here. So Glassfish HK2 alphabetically comes before Jersey. So I'm going to make sure so I've got some of these orgs should be down below this Jakarta. So let me move this up just to keep these sorted a little bit cleaner. All right, so now these look alphabetical. Everything should be good now. Okay, now we're getting convergence problems. So we've got Jersey HK2 and HK2 API are using different versions of AOP Alliance. So this one here is older, so we need to add an exclude for this one to our Jersey HK2. All right, so we're going to use the newer version from HK2 API. Now, for this one up here, excuse me, Very similar issue. We've got 301 used by Jersey HK2 and 302 used by HK2 API. So we're going to exclude this dependency from Jersey HK2 for the same reason. Okay, now keeping these sorted alphabetically, we'll go ahead and do that. All right, hopefully now we're at a point where everything builds successfully. It only took 10 minutes to figure out these build issues. All right, now we're looking good. All right, so now we're pushed up, everything's committed. We'll go ahead and minimize this REST module. We'll close out some of this stuff here that we're not interested in anymore. All right, so what we want to do is add some configuration support to this instead of hard coding these strings. There are a few different configuration libraries. One thing that we're not going to want to put in like a configuration file is this port. I'd like to be able to pass this in on the command line. So that way when we run the server, we can pass in the port from the command line, and then that will allow us to easily run multiple servers on different ports. And then those individual servers can look up all these configuration properties themselves once they're started. But the ports will be effectively hard-coded on the command line when we start the server. So let's do that part first. We can say int port equals, let's say, now, so we're not going to get it from the command line parameters passed in. Let's get it from the system environment or the system properties instead. So I'll say I will do optional of nullable system get property, and we'll say port. Now let's statically import this. Now get property returns a string. We need an integer, so let's map this to integer.parseInt. And if it's not there, we'll do or else throw. Actually, we'll do or else 8443. So that way we can run this server locally without any configuration. We can just hit this play button and it will use 8443 as the default port. So I'll go ahead and replace this 8443 with port. And in fact, I'll update this login message down here. Okay, so I'm passing in, I'm using these curly braces for string interpolation with my logger. This is the correct way to do it. What you don't want is to do string concatenation. Potentially, if we've got the logging configuration set where info things aren't printed, we're doing extra work here by concatenating these strings, right? We're using memory to do that, and basically making copies of strings and things. So that's what we don't want to do. What we want to do is use string interpolation so that this logger will only update these strings and inject this port into the log message if the logging level is configured as something at the specified level or lower. So this is a common issue that I see a lot. Basically, always use string interpolation when you can. If you're going to do very complicated or expensive logging, you can add a wrapper around it, like is info enabled in this case, right? But generally, you don't need to do this. The logger itself will do this. Like if we dug in here, like to the various implementations, like it might take a little bit, but somewhere down in here, like one of the first things it does is verify that you actually have your logging set at a level to do this. But if you need to do a lot of work to calculate what to put in here, right, like whether you're calculating the size of a table in the database or something like that, if it's expensive, then you might want to wrap it in this so that you don't do that expensive work. But generally, like for something like this where there is no work to calculate what the parameters look like, there's no need to do that validation, that logging level check. Okay, so tangent aside, we've now got our port that we're accepting. We can still run this process from the command line here in our environment. We're not specifying a port as a system property, so it does fall back to this 8443. We can see it here, and we can see it here as well in the Jetty logging. Now, if I update this configuration a little bit, so let's see, we've got program arguments, we've got environment variables that we can configure somewhere in here. Like I should be able to specify, VM options. So if I come in here into VM options and say -D port equals whatever, 8,000, apply, okay, and then hit run here. Okay, so we picked up our port system property, which we specified as that -D parameter, and successfully read in the port that we passed in from the command line. So this allows us to, like, we could start multiple servers, each on a different port, just by changing what we pass on the command line. So let me go ahead and edit this configuration and get rid of that, because we don't actually need that. So apply, okay. All right, so at least this is a step in the right direction. We've updated our port. Everything else, like all these other things, we'll get from a configuration file. And so we'll start on that in the next video. In the meantime, thanks. Have a good one. See you next time.